Hello and welcome to the Tau update for December. And this is the dev team call. So I'm going to pass it over to Karim for his overview for the month.
Thank you, Fala, and welcome everybody. Since this is the last update for the year, I thought that I could give you a quick overview of the development progress that we've done so far this year. So as you well know, our development has been going on two major tracks. The first one is on the Agoras Live web application, which is essentially a nucleus for the Tau system. And of course, also TML, the Tau meta language, which is the core technology behind or at the core of Tau. We will be using it both for translations between languages, but also as the main core technology for our logical solvers. Okay, so on the TML side, or no, let's start with the Agoras Live side. On the Agoras Live, we can say basically that the application has been fully developed, and modular sim testing will be ready for deployment early next year. But in the past year, we've went through several graphical redesigns of the interface itself based on initial feedback we got from some users. And we've added, of course, web wallet crypto payments and authentication through the web wallet. That's how you basically log into Agoras Live. We've added the concept of public sessions where teachers basically can hold open sessions that anybody can join. We've added a lot of call management features, including a My Sessions feature for teachers and students to manage their history of sessions, but also calendar functions for future sessions. We've also added peer-to-peer reviews between the users, between all the users of Agoras Live, both teachers and students. And then that was it in terms of functionality. Towards the end of the year, we started looking at the overall architecture of the application with an eye towards deployment, DevOps, and scalability. And we've actually ended up refactoring the entire backend, and in the process also fully documenting the backend in order to make it easier in the future to maybe even re-implement the front end. So yeah, that's it for Agoras Live. Hopefully sometime early next year, after we've done our testing, we should be able to release version 1.0 of that. On the TML side, a lot of progress. I think we've accomplished all the features that Ohad had set out for us at the beginning of the year. We have a TML 1.0 version ready to release and test for you guys. Actually, it's been available for a while on what we call the TML IDE that Tomasz had laboriously developed. So the TML IDE essentially is a tool, a web-based tool that you guys can use to look at several examples of TML programs that you can edit, play with, look at the output. So I know some of you have been playing with it. Yeah, Tomasz added a lot of improvements to that, including syntax highlighting. We've also have syntax highlighting of TML in VS Code or Vim, if that's your favorite editor of choice. So you can write TML in VS Code if you wanted to. We've also added a lot of built-ins into the TML language itself, except built-ins are essentially external functions that you can call in TML. So it could be things like printing or any advanced arithmetic functions that you wanted to do. We've extended also the TML syntax to allow for multiple built-ins into one rule, but also we've added caching for the built-ins, and there's also now an API to implement your own built-ins if you wanted to roll up your sleeves and do that. Then we tried our hand at solving at least one practical problem in TML, which is, or at least a well-known problem, which is the puzzle game called Sudoku. So Tomasz implemented that in TML actually, and using several approaches, and but we learned some very good lessons on that, both in terms of TML performance, but also we added the new thing called state blocks, which helps with the control flow of TML. And we've continued to basically push the capability of that script 10 IDE built into a web browser. I mean, it's very capable. It does basically almost everything that you can do on the command line. And but also we're working on the persistence of TML programs, which has something to do in the future with what we call the BDD network and the ability to store and retrieve and cache logic computation. So that's also a very important line of work. On the logic portion, of course, Juan extended the first order logic functionality of TML, but he also worked on a second order logic. Not necessarily a complete solution, but a first version of second order logic that is very useful in some cases. Juan also extended the arithmetic operators. He actually re-implemented them just to enhance performance, and experimented with several approaches of second order logic, which, as you guys know, is a very hard problem. But Juan started out the year by migrating the AGRS token from the Bitcoin Omni layer, which we were in at the beginning. And so we moved the AGRS from the Omni layer to being an Ethereum ERC20 token, and which allowed us to list AGRS on several crypto exchanges. So that was a major step for us. And then on the again going back to the TML core functionality, Umar has done a lot of work on extending the syntax of TML. So now we can specify the syntax in eBNF. So that improved the parsing performance. He also added regular expressions. We added macros to TML. But also a major improvement was conversion of a universe of size 2, which kind of an internal optimization, but it's a very important one. He also added specific types to TML, so where you can specify the exact number of bits per variable, which helped a lot with performance, and also added type checking and type inferences, which have made the TML a much more robust programming languages. And we continue to push the envelope on the capabilities of TML. Next year, we already started working on what's called an early parser, which is a very powerful parser engine. So yeah, same thing for TML 1.0. We think we're ready to release a version next year, but we continue to work on TML as our core technology for Tau. That's it for this year, and I'll let the team members each explain in more detail their contributions. Thanks, Fola.
Thank you very much, Karim. And I'll pass it over to Juan for his update for the month.
Thank you, Fola. Yes, well, Karim initially shared with you, we're trying to give a overall year's update to bring some good conclusions, but to try to describe which were the major milestones that we achieved. So yes, as Karim pointed out, I did work on the logic capabilities of our system. So I fixed several bugs to the first order logic feature with the support of the other team members, particularly Tomasz, Luca, and Muricy, who all of them found issues in the implementation. So I addressed those functional bugs. And I also extended in particular the first order logic with the uniqueness quantifier, which is running for computing on the BDD layer. So it's a built-in or slash a primitive handler. So with regard to the arithmetic capabilities, I did a reimplementation of our count. I mean, it's the count handler or built-in. Plus, I redesigned the over BDD addition, which is another which is operating directly on the BDD data structure, from which we are expected to have relevant performance gains. In the short term, we will be testing those new capabilities, and also the less or equal built-in, which is also running directly on the BDD data structure, which is compatible with what is the new bit universe transformed programs that Umar put together during this year. Of course, there is a lot of possible work to be done on arithmetic. We have remaining to do some work on the logarithm function, and there are many possibilities to extend the system with regards to its arithmetic capabilities. But yeah, it's likely that we may want to focus also on primitives or on handlers, also related to what it would be a blockchain, let's say like crypto primitives, networking, and also some shared memory or global memory synchronization and access between the nodes of the system. So there are some relevant decisions to be made. We are working on them, and it's likely that built-ins, as the concept of the built-ins may grow in different flavors or in different directions, say arithmetic or the other primitives that I commented with regard related to what would be a blockchain or a distributed system. And finally, I did participate during the whole year into in the Tau academic panel sessions, which of course was a very intellectually demanding task, just by listening what the elaborations that are being done there. And yeah, in particular, I'm looking forward, or I'm especially putting the attention in what are the automaton related aspects of the system, and also related to a hypothetical machine that may help to address some problems related to the system. So there is a very interesting theoretical computer science work that is being done there, of course, as well as logical and mathematics, really in some way enjoying what is being done with the professors that are accompanying us in there, and also, of course, with OHAT's lead there, which is also, it's usually so we're searching into new horizons, and really the state of the art in computer science, I would say. So yeah, we are trying to tackle a very hard problem, very rough one, and yeah, hopefully we will continue improving the solution that we are figuring out. So yeah, I think that would be the some closing lines for this year. Thank you.
Thank you very much, Juan. I'll pass it over to Luca.
So this month I continued studying the theory of algebraic effects, which I had started last month to study. And in addition, I also looked into how monads in Haskell exactly work and what their use cases are. And I did that in order to understand let's say the general theory of side effects better in order to contribute ideas on how we can enable side effecting programs in our language we are developing. This is ongoing work and it's also discussed in the academic panel. But yes, and then on a different path, I have continued the development of the 2CNF extraction feature. And then there I further enhanced the shared universe for the 2CNF formulas. And that in particular meant the implementation of a canonically persistent shared data structure which can hold implications. So basically elements which have a first and a second component. Yeah, and that's pretty much been this month for me. And I'm looking forward to a new year. And I'm very excited to work on solving the challenges that we encounter. And thank you very much for listening.
Thank you very, very much, Luca. Your updates are always awesome. And now I'll pass the mic to Tomasz.
Thanks, Fola. Hello, everyone. So my accomplishments in the year 2021. First, it's the TML online editor, which is available at tml.idni.org, where anyone can try TML online on the web without installing or compiling anything. And it also contains a lot of examples of various TML features. Next was TML syntax highlighting for the online editor, and I've also made syntax highlighting extensions for VS Code and Vim editors. Regarding TML itself, I've reworked built-in support, so devs have better API for defining new built-ins. Variables are grounded when used in built-ins. TML programmers can use multiple built-ins per rule. They can control cache of built-in results to control how often is every built-in called. And I've added various built-ins for printing to output streams of TML. Then I was trying to write some more complex programs in TML, namely Sudoku solvers. And from this endeavor, I've come to a conclusion that TML needs a new syntax construct to make complex TML programs more readable. So I've implemented a new structure called state blocks. I've also continued to maintain JavaScript build of TML by using mscripten. And finally this month, I've been researching usability of a Boost interprocess library for persistence of TML. So that's all from me this year.
All right, thank you very much, Tomasz. I'll now pass it to Andre for his update this month.
Hello, everyone. This is really heartwarming for me to say by the end of this year that we have the Agoras Live platform in its basic state ready. Of course, we plan more features to come, but after the release, so all I was doing this last month, I was polishing the code. I was writing some more documentation that we needed, and I was making sure that, for example, a tester can run backend queries right inside Swagger, and we're looking forward for a tester report to finish building this basic Agoras Live platform and release it pretty soon enough. Thank you, everyone. Have a great holidays. Happy New Year. Merry Christmas. See you next year. Bye.
And thank you very much, Andre, for your update. Very much appreciated. I'll pass it to Umar for his update for the month. Over to you, Umar.
Hi, team. I'm glad to report the progress of December. So the good thing is that in this month we have made a significant contribution in terms of turning the recognizer into a parser. Previously, for any given sentence, early recognizer could only say yes and no, whether the sentence matches the grammar or not, or is part of the language of the grammar or not. But now with adding the parsing capabilities, we can not only see the syntactic structure of how a given sentence is derived, but also we are also able to encode um, or represent and store that syntactic structure compactly in a graph. And that's crucial because there are many cases where for a given context-free grammar with ambiguity, you can have exponential number of uh, of individual parse trees, and that will be very cost prohibitive in terms of in sort of storage. And so one of the things that we spend time in this month is how to have the right data structure to store the parse forest. And having done so, we have tested it with different grammars from the literature, from the research papers, because that's where some of the tricky test cases were presented. And then we are now in the process of fine tuning it, optimizing it, and making sure it becomes more efficient. Um, Also, we are in the process of trying to complete the end-to-end workflow here. That given any input sentence and a given grammar, how we can construct a parse tree and then turn that parse tree into TML facts, so that TML programs can use those facts to make changes or process them or transform or translate them into other syntactic structures. Yeah, thank you.
Umar, thank you very much. Always great to hear that you've been up to some really, really good stuff this month. And last but not least, Ahad, over to you for the wrap up of December.
Well, this month I continued what we spoke last time about how to enhance our logical framework to be able to specify programs, because after all, Tau is a program and it's all about users controlling this program, being able to specify it by means of consensus. It is not a difficult task. There are many formalisms in the literature of how to represent programs in logic, but they don't answer our basic requirements of either they don't answer the requirement of being pure logical. So it makes sense to specify programs by means of consensus, which is what we want. Most of the specification languages out there don't have that thing. It is meaningless to speak about consensus in those languages. And the other difficulty is that even if we are able to specify programs in pure logic and have meaningful consensus, this logical framework should fit the other logical framework of ability to speak about truth inside the language. So this month and also in the next month, the big effort in specifying programs under this framework is continued.
All right, thank you very much, Ahad, for wrapping up the December update. And thank you very much to the community for tuning in. And we'll be about, so we'll see you on the usual Telegram and Discord and in your future Q&A questions. Have a very, very Merry Christmas and a very happy New Year. Cheers.